Let me solve one more working example of differential equation. A barrel contains 100 liters of a solution of 80% white color and 10% red color. Another solution composed of half white and half red will be added to the tank at the rate of 6 liters per minute, while at the same time the tank will be drained at the rate of 6 liters per minute. If the solution is stirred constantly, how much red colored beverage will be in the barrel after 8 minutes? What the statement says that there are 100 liters of solution, where 80% is white colored and 10% is red colored. There is another solution which is half white and half red. The second solution will be added to the first solution at the rate of 6 liters per minute. But at the same time the tank will be drained at the rate of 6 liters per minute as well. If we mix the solution constantly, how much red colored beverage will be in the barrel after 8 minutes? This is the task, to know that how much red colored beverage will be in the barrel after 8 minutes. Solution. We follow this model, which is dy or dt equals to input rate minus output rate. So based on that model, our equation will be dy or dt equals to minus 2 times y over 100 plus 1, which is a simple ordinary differential equation, where this 100 is the 100 liters of the first solution, and y is the second solution added to the first solution. Now separate the variables, you will get dy or dt plus 1 over 50 times y equals to 1, which I can write y prime plus 1 over 50 times y equals to 1. This is a simple linear differential equation. If you don't know about linear differential equation, go back and see the section linear differential equation. It is a typical example of linear differential equation. And here you will see that how we use a linear differential equation in our daily life. This is my P of t and this is my Q of t. To solve the linear differential equation, we need to find the integral factor, where the formula of the integral factor is here, which is I equals to e to the integral of p of x dx. This is the formula of integral factor. Put the value of p of x, which is 1 over 50 dt. Since we have taken the values in the form of t, therefore just put the value of t for x. 1 over 50 is our p of t, and d of x is dt here, where integral of 1 over 50 dt equals to t over 50. This is my integral factor, e to the t over 50. Now put integral factor in the general solution here, where the general solution is 1 over e to the t over 50 into integral of e to the t over 50 times 1 dt plus c. This is the general solution. Just substitute the value of integral factor. E to the t over 50 is my I, integral factor, and 1 is q of t. Shift e to the t over 50 to the numerator and integrate the e to the t over 50 to have e to the minus t over 50 into 50 times e to the t over 50 plus c. Simplify the equation to get y equals to 50 plus c times e to the minus t over 50. Now to find the value of constant c. To find the value of constant c, use the initial condition where y equals to 6, t equals to 0. 6 is the number of liters per minute at t equals to 0, which is my first initial condition. Just go and check the statement which says that another solution will be added at the rate of 6 liters per minute. So y equals to 6, 6 is the liters per minute at t equals to 0. Just substitute the value of y and t in this equation to have 6 equals to 50 plus c times e to the minus 0 over 50. We just substituted the values 6 and 0 in this equation. Simplify the equation further, you will get c equals to minus 44. This is my arbitrary constant value, minus 44. Now my task is to find that how much red color beverage will be in the barrel after 8 minutes. So just put the value of t equals to 8 minutes here. So my equation is y equals to 50 minus 44 times e to the minus 8 over 50. My timing t is 8 minutes. Minus 44 is the value of constant c. Solve the equation to get 12.5 liters. So 12.5 liters a red colored beverage will be in the barrel after passing 8 minutes. That was one working example of linear differential equation. Now you go and check some other practical examples in your daily life and solve them in the exact way.